So the last thing we're going to talk about in this section is we're going to model a sine function. So this example right here is going to model the temperature for New Orleans. And we can see here that we have the monthly temperatures all the way from January to December. And we are going to graph this and be able to determine an equation of this graph. So I'm going to walk you through the steps to be able to do what we would call a regression. And in this case, because we know that this is going to be something similar to a sine function, we're going to do a sine regression. So the first thing we need to recognize is we cannot put January, February, and so forth into our calculator, but instead we're going to let the months be represented on the x-axis, and each one would start, let's see, we want this to start at 1, 2, 3, all the way to 12. 4, 5, 6, 7, 8, 9, 10, 11, 12. So when we do a regression, we're actually going to be doing this based on some lists. So we're going to let the x values, or our independent variable, be the first list, or list 1, and the temperatures, which is our dependent variable, would be list 2. So in other words, these are the x's and these are the y's. So I'm going to pull up my calculator, and I'm sure you'll be able to do this a lot faster than me. Let's see if I can make that a little bigger for you. And I want to go, since I'm going to be putting these into lists, I'm going to go to stat. So stat has these options right here, and I'm going to edit. I'm going to choose that first option, and you can see it brings me to a whole bunch of lists. Now, if you have data in your lists, then you can just arrow up. See how it highlighted the L2 for me here? And I can clear that data, and then you hit enter. And by doing that, it deleted all of the data that was under list 2. So I'm going to arrow over to list 1, arrow up until L1 is highlighted, hit clear, enter, and it deleted all of that data right there. So I'm going to go through and I'm going to enter all of the data under list 1, which is basically I'm going to enter the numbers 1 through 12. So I just hit 1, enter, 2, enter, and so forth. I'm going to do that, and then I'm going to pause the video and come back. So I want you to make sure you're doing that too. Okay, so you can see the rest of my list that I have here ending with 12, and I'm just going to arrow over, and it starts all over. See, I'm at the top of the L2 list. From here, I'm going to enter the corresponding temperature values. So the first number I'm going to enter is 53, because I know that 53 corresponds with number 1, or January. Then I'm going to hit 56, and so forth. I'm going to do that all the way through till I get to this 55 down here. And it takes me a little bit longer on the computer, so I'm going to pause this and enter it, and I'll come back to you, but you do that as well. Enter your data. Okay, so you can see I have all of that data entered right there into the second list. Well, all that did was basically enter 2 tables of data into the calculator, and I want the calculator to now plot this data. So I'm going to come over to the y equals, and you can see up here, this is one way to do it. You can see here where my cursor is highlighting, it says plot 1, and I'm going to turn that plot on. So I arrow up to where it's highlighted, and I hit enter. Now if I arrow down, you can see that plot 1 is highlighted, and that means that the calculator is going to plot any points that are in the lists. So let's go graph this for a second and see what happens when I do that. Nothing, right? I don't have anything that's showing up on my data, which tells me that I need to do some adjusting to my window to be able to see this graph. Well, if we come down here, we know that if I'm looking at the x-axis, which is my first list, what is the maximum number of values I have on that list? Well, I go all the way out to 12, don't I? So I'm really only looking at values between 1 and 12. So I'm going to change my window to reflect something like that. So the minimum value I would need was a 1, but I always go just a little less than that, so I'm going to put a 0 in. The maximum number I'm going to get is a 12. Well, if this is truly a sine function, we're expecting something to happen within this period, so I don't know, I'm going to double that. I'm going to say, well, what happens if I want to see 2 pictures or 2 periods here? So I'm going to put 25 in. I would like this to increment, which is the scale, by 1. Okay. Now let's talk about the y values. That is the list 2. So I can see here that I have a 53, which is my smallest value, and it goes all the way up to, it looks like, 83. So I'm going to put my minimum value to be at 0, but I am going to go up to, I go a little bit past my max, and so I'm going to go to 85. But I don't want to see 85 tick marks. So instead, why don't we increment by 5s? Now I don't know what x-res is, so I don't ever want to touch it because I don't know how to put it back. So I'm going to leave this as my window. Now let's go graph it again, or plot the points, and see if it looks better. It does, doesn't it? Well, what if I wanted this? I can adjust my window, and if I don't want my graph floating up here, then I can change it to where we start at my minimum value of 53. Let's go see what effect that has on my graph. Instead of starting at 0, what if we started at, let me get down to it, this is 53, so what if we did between 50? I want to see what happens to the graph between 50 and 85. It's kind of interesting, isn't it? This is all the data that I have right there. Okay, so I'm going to save that image into our notes. Now, I know that this is the plot we have going on here, and I can see that this is some sort of function, right? This is some sort of trigonometric function. So when we want an equation based on what we think are some points that form a function, then we call it a regression. So I'm going to go to Stat. I'm going to do Calculate. And you can see starting about number 4, I have all of these regressions listed. I could do a linear regression, a cubic regression, and so on. But I'm going to arrow down until I find the one that has to do with trig. And that would be the sine regression. That's the one I'm going to choose for now. So the calculator is waiting on me to do something. It says, okay, sine regression, what about it? So I'm going to say, yes, please call the sine regression. Now what it did is it went and took those 2 lists, lists 1 and list 2, and it did a regression based on those numbers. And notice that it gives me an equation for sine, and then it lists all of the amplitude, the period, the phase shift in this case, which is inside of the parentheses, and the vertical shift, which in this case is outside of the parentheses. So I'm going to copy all of that information down here. Let's put it over here on our paper. Okay, let me move things around for just a second so I can see some stuff better. Okay, so I have the graph over here. I have the calculator figured up the regression, or it came up with, in other words, an equation. This is the equation, what it's going to look like, and all I have to do is replace the letters with what the calculator told me they were. So right underneath that, I'm going to copy down this equation because I'm going to enter this equation back into my calculator in a second. So I know that this is in the form y is equal to a, which is 15 point, I'm going to go to 2 decimal places. I think that should be enough. 15.57 sine of 0.51. That's the b value in this. Then we have x plus c, which is a -2, so it's going to be minus 2.02. Now let's add the d, which was the vertical shift, plus 68.44. Okay, so I'm going to go back into my calculator, and I'm going to ask the calculator, well, if this is the equation that we think is based on this data, let's graph it and see what we get. So I'm coming back over here. I'm going to go back to the y equals. Now you see that the cursor is flashing under y1. That's where I'm going to enter this information. 15.57 sine parenthesis. Oops, it's already got a parenthesis. Let me back up. Let's enter the b value, which is 0.51. Then we choose x minus 2.02. Close the parentheses and add 68.44. Now let's go graph that on top of what we already had and see what happens. Ooh, that's pretty close, isn't it? And then we got another picture right there. So a regression allows us to take some data that we may have collected, come up with a general equation that fits that data so that we could then perhaps predict what's going to happen in the future. So this is what I would assume would be the data for 1 year. And if the next year's temperature in New Orleans follows this same pattern, then I would be able to predict what the temperature would be for the following year. And that's what a sine regression, or that's what a regression allows us to do.